What's up guys, this is Teddy. Welcome to my YouTube channel. This video we're going to be talking about the stack data structure. And the stack data structure is going to be one of the most common interview questions that you get. You will get stack interview questions as a junior developer, and this course isn't going to be even that difficult. A stack is pretty easy to code up, it's pretty easy to understand, and this is almost just like a gimme in the world of data structures. Just, I would say, even junior level developer, junior level self-taught developer, definitely pay attention to this, because a stack is going to be almost like the fundamental building block, and a lot of data structures are going to be built upon this. So definitely do not skip any parts of this video. So we're going to go ahead, we're going to jump into the whiteboard. I went ahead and I bought a fancy Wacom tablet, and I'm ready to show this thing off. And whenever you think about a stack, and the most common example that you'll ever see is going to be a tube of tennis balls or a stack of papers. And I have like a stack of papers here, or just kind of like a stack of, not even papers, just like a stack of like random stuff. And I want you to think of a stack as sort of papers and envelopes on your desk whenever you're about to pay your bills. And what you do whenever you're paying your bills and you're avoiding paying your bills, like I used to do, and there's nothing wrong with that. We all used to do, bad stuff at one time. But when I used to avoid paying my bills, what I would do is those bills would just boom. Those bills would just pile up. See, that is why we call it a stack. It's just, you're just piling it on. All those bills are getting, that stack of bills is getting higher and higher, and you're not doing a thing about it. And that is the process of a stack. It goes on, and you're never going to reach in. You're never actually going to pay any of your bills. So you're always just going to take bills off the top, and you're always just going to stack them onto each other. And I'm just kidding. You guys work in tech, so you probably have money to pay your bills. So, that's just a joke. That's just an analogy. But another analogy is going to be a tube of tennis balls. Whenever you are, and if you never played tennis before, that's okay too. Whenever you put tennis balls into a tube of tennis balls, and if you play tennis a lot, I used to be really good at tennis. You do still use the tubes. Like, it's not like you don't buy some like fancy bag to keep all your balls in. Like, you still use those tubes because they have a seal on them. So you use those tubes a lot, if you know what I'm talking about. But just like the last in first out, or just like the analogy, let's just slow down and let's think about, we have such a bad habit of getting these fancy acronyms that we don't ever even slow down and think about, like, what does last in first out actually mean? So last in, let's just say we put some tennis balls in here. So we just put 2 tennis balls into our tennis ball canister. And we can't reach into we can't fish out like the bottom one. Like, we literally have to take them out in sequential order, like just like the pile of bills or the last in first out. So whatever tennis ball we put in last is the one that we're going to take out. So we'll take out a tennis ball, and that tennis ball is going to go away. So tennis balls go away, and that is pretty much the process. But we don't just call that. We don't just say the tennis, the objects or the integers in the stack are just going away. We have special names for them, and that is going to be a push and a pop. Whenever you are pushing onto the stack, you're putting tennis balls into the tennis ball canister. That is the push. And I know my handwriting is terrible, and I'm not even going to make like the dumb joke. Like, every single teacher makes like the dumb joke about like how their handwriting is bad, but we all know my handwriting is bad, and I'm not going to make the corny joke about it. But I just kind of did, so moving on. Okay, so, and then when you want to take a tennis ball out of the canister, just think of it as like you're just popping it out of the canister. You're pushing tennis balls you push tennis balls into the canister, you pop tennis balls out of the canister, and that is pretty much it. There's really not that crazy of an action, but you also have this word peak. And peak is going to mean that you're just looking at the top you're looking at the top ball in the canister. There's really nothing, it's just kind of the way it sounds. It's a funny word, and those words are only going to be used whenever you're coding stacks, but it's just sort of a terminology that you need to have. And you also have a top too. Whenever you whenever you talk about stacks, just remember that there's always a top of the stack. And as you put, and I don't know what happened there. So let's just say I push a 1 onto the top of the stack. It goes down here, and that is the top. It's like the top and the bottom, but we don't actually have a bottom. The only thing that we have is a top. So then we put another one on there. We put another, tennis ball, and let's just say we put like a 42. And now that's the new top. And then let's just say we put like a negative. We're just putting integers in here. You could put strings if you wanted to, but I'm just going to put integers just to, not confuse anybody. That is the new top. And then when we pop, we get rid of it. Boom. Our new top is right there. And you guys get the picture. So then we pop this off. Now our new top is right here, and that's pretty much it. And then we pop this one off, and that's it. And then when we want to peek, we're getting the very top value. So if I just put one more value and then I ran peek, it would show, it's just going to return, or it's going to, quote unquote, show this one. So another thing that you want to be aware of is the time complexity. And the time complexity is going to depend on which underlying data structure you use. And if you haven't talked about linked list, I'm going to separate this into 2 videos and assume that you already know about arrays, but linked list is going to be the ideal data structure for a stack. And a linked list is going to make it so that your insertion here is going to be O1. And O1, remember, is the Cadillac. O1 is constant, and that's the one that you want. With an array, insertions and deletions are going to be ON, which isn't the worst. I call it it's the Honda Civic. It's not the worst, but it's not the best. O1, the linked list, is going to be like the Ferrari. That's like the one that you want. It's constant, and that's going to be the one that you're going to try and shoot for. But you really need to know both of them. And you may not have watched the linked list video yet. So I'm going to split them up into 2 videos. We're going to do array first, and then we're going to do we'll do linked list second. So let me see here. And let's go ahead and recover this. We're going to go ahead, we're going to go into Visual Studio, and we're going to actually start working on this thing. So bring this over here, and let's see. Go ahead, and we're going to code up this stack. So go in here. I'm just going to add a folder, and if you're just kind of already in Visual Studio, you don't even have to do any of this. I'm just going to put a folder in here because it's like a whole entire course. So we're going to go stack. We're going to go add. Just call this a stack. And we are off to the races. So first thing is we're going to add our properties. And I'm just going to go give this a prop, and we're going to give this, and we're going to give this a max size. And you have a max size in array stacks because, and I'm actually just going to put this comment here and just kind of explain to you what each and every property is. So with array stacks, you need a max size to init array. So if you're gonna be coding up an array stack, you got to have that max size. Otherwise, you could just hard code something in there, but I wouldn't recommend that. So we're gonna go over here, then we're gonna go prop, and we're gonna go. This is what's the array that's actually going to hold our data. And you could make this anything. You could make this an array of objects. Like if you wanted to put anything in there, you could make this an array of integers. But I'm actually going to make this an array of strings because I want to put Pokemon names in my stack, just like I always do. It's just something I like to do. I don't know. All right, so we're going to go int, and then we're going to have the top. And as you've seen, or as you witnessed in the whiteboard, we have to have that top because it's almost like it's going to keep track of where the actual top is for us. Otherwise, there's no pointer. There's nothing to actually keep track of the length or keep track of like where we actually are. So we're going to go in here. First, let's go ahead. We're going to initialize that max size, and we're going to toss in the size. let me see here. And what we're going to do is we're going to have our int, we're going to have our size in here. So if you're not aware, this is a constructor. We're going to go ahead. So whenever we initialize our stack, because it's an array stack and it's not dynamic, we have to actually have this size here. So when we initialize it, and I'll show you guys what a constructor is. If you don't know what a constructor is, I'll explain this later. Kind of a little bit beforehand to actually understand what this is going to do, but just kind of follow along and you'll understand what it is here in a second. So we're going to go here, then we're going to have a string, and then we're going to have our max size in here. So we're going to go max size, and that's going to initialize our array with the max size. Then we're going to go down here, we're going to have our top, and we're going to initialize the top as -1. And this is because we don't want it to be initialized as 0. If we initialize it as 0, it will skip the first element in the array. So I'm actually going to put some notes down here. We give top -1 because array is 0 index. If we don't, it will skip first element. And I'm just going to go here. The stack, this is going to create array and new up size. Actually, that doesn't really make sense. Creates array with size. Okay, and then the max size, that's actually just going to be the thing that holds the constructor value. So this holds constructor value. This holds constructor value. And stack array, let's say this holds our array. This keeps track of the top. Awesome. So now we have what is going to actually create our array when we actually initialize it and assign the size. These are going to be what holds all of the properties and all of the data that's going to be housed in the array. Think about this up here as like, this is going to hold all the data, just like the abstract data type video. If you didn't watch the abstract data type video, you want to, go watch that video because that explains a lot of what's going on. So this is all the data that's actually being held within our abstract data type, our stack. Down here, the methods are going to be what actually act on it. And the methods that we're going to do are push, pop, peek. Those are going to be what actually manipulates all of our data. Pretty simple. Sort of. It's a little confusing. I know that data structures are hard. Okay, so we're going to go void, and then we're going to push onto the stack, and we're going to have string item. Then all that's going to happen is we're going to increment this. We're going to increment the top of the stack by 2, and this is as simple as it gets. And another thing too is we're going to have to go back and add error handling to this, because if we just have it so simple as I'm about to make it, you will run into errors and you will run into issues if the stack fills up, or if there's nothing actually in the stack, or if the stack is full. So if this array is full, if it goes to the max size and you keep pushing and there's no error handling in it like there is right now, it's going to show an error, or it's going to give an out of bounds error. But we won't worry about that right now because we're having fun and we don't want to worry about stuff like that. So now we want to pop off the stack and we want to return the actual object that we pop off. So we're going to go pop, and remember what pop is. So push is you're pushing onto the stack. Push is you're going boom, you're putting tennis tubes into the bottle. Pop is you're taking tennis balls off the bottle. So it'd be like boom. So that's the push, that's the pop, and the peek is you're just looking at the very top one or you're basically getting the top. That sounded kind of strange. So, all right, onward. So pop, if you just want to and you don't want to do any type of error handling, like I'm going to show you like the most bare bones stack that you could possibly make. So we're going to go old top is equal to the new top, and this is pretty much just a placeholder. Then we're going to increment the top. We're going to decrement the top because remember, we're going down and the top is like the actual logical one. And then we're going to return this. We're going to actually return the top of the stack. So we're going to go stack array and then the old top. And we do that because that's the old top is a placeholder. So this is think placeholder. Because if you just delete it, you'll just delete it. So in order for you to actually be able to delete it, you need to put it in a placeholder. You need to decrement that top, and then you need to just, toss it off the stack. And I'll just put a comment right here. Okay, this is decrement for the new top. Okay. And for this one, as you can see, because we're pushing, the top is going to go up. Increment, remember, whenever you're pushing and whenever you're adding stuff to a lot of these data structures, pay really important attention to what you're decrementing. You're decrementing this. And this one, you're actually adding to the top of it. And it's really simple. It's, you just increment it by 1. So you have a new pointer. So I'll just go ahead and I'll actually go into here. So what's going to happen is you have a new pointer and it's got a new top, and then you're just going to put the 2 into there. And that's pretty much it. And let me just actually, so let's say we have our top is initialized as this. Then we have, in our top, remember that we actually made it -1. So our top is actually -1. Then we added to it. And then we have a new top, and the same thing is going to happen. It's going to increment our top, and I don't know why it keeps doing that. So it's going to increment the top, it's going to go up, then it's going to have a 2, and then that's pretty much it. And the same thing happens on the other one. The old top's going to be held in a placeholder because we can't actually delete it. It's going to be decremented, and then this is going to be taken off, and that's pretty much it. It's not like complicated at all. It's one of the easiest data structures, and I hope that didn't absolutely confuse you. So next thing we're going to do, we're going to go down, we're going to go string, and we're going to go ahead and we're going to do our peak. Okay, and the peaks are very easy because you just get the top. You just literally have the top, and what's going to happen is our top is already where our peak is, and we're just going to access the index of where the actual top is, and it's just going to, give us the top. Very, very self-explanatory. So whenever we make these data structures, another thing that we're actually going to have to, I don't think worry about, but another thing that we're going to do is we're going to make helper methods. So we're going to go public, we're going to go bool, and we're going to have empty so that we can actually iterate over through all this stuff. Otherwise, it's going to be really hard to actually utilize any of our data structures because there's no actual methods that you get. You see, when you make your own data structures, you don't get all of those cool little methods built into it. So whenever, if you don't actually create them or you don't bring them in with an IEnumerable, you could also bring them in with an IEnumerable. They're not going to be there, and you're not going to actually be able to use them. So you kind of take for granted all those cool little methods and all those, array.length and all of these cool things that we get to utilize because when you don't code them, they're not there. And if you're making your own data structures, it's, nobody's gonna actually build all of these things for you. So next, we're gonna check if it's full. So if the max size is -1 is equal to the top, then it is full. Okay, so let's go in here. We've already got this nice little beautiful stack built up. Let's go into our program file, and we're still got all this stuff from the linked list video in here, and we're gonna bring in our stack. We're gonna go up here, we'll go stack, and make sure that you bring in your own stack and not Microsoft stack. So we go here, we're gonna go stack, and let's actually, oh, never mind. I'm not even taking my own advice. We need to bring in our stack, algorithms and data structure course stack. Okay, awesome. So looking at this, you will notice that we are getting a red squiggly line. And the red squiggly line is because we don't have this. And if you hover over it, you'll see that there is no argument that corresponds to the formal parameter size of int. This is basically saying you made this, and this is required for me to actually make this, but you didn't actually supply it, so you need to supply this amount. And let me see here. We're going to go here. We're going to go pass in. Let's just say we're going to initialize this to 10, and that will be our stack. So now let me see here. Let's actually iterate over it, or let's add some values to this. And I think a great way to practice adding some values to our new stack, int I is equal to 0, I is less than 3, then we're going to increment it. So we're going to go in here, and we're going to go stack.push, and we're going to go Squirtle stack.push, and we're going to go Pikachu, and we're going to go stack.push, and we're going to go Charmander, and also we're going to put our push pop and peak. So we're going to go stack.push. We're already doing our push. Let's do some pop. So we're gonna go pop. We're gonna pop that off. Then we're going to do a peak. So we'll do peak. Then we're going to go Squirtle is empty. Let me see here. Actually, let's go ahead and let's utilize our while function. So we'll do Squirtle while Squirtle is not empty. And whatever's left, we'll pop it off. Popping it off. It's gonna pop off. Okay. Don't tell anybody I said that. Okay. So take this down here, and then when we do that, we're gonna go var value. So let's say var value is equal to Squirtle, or not Squirtle, we're gonna go stack dot, let me see. And then let's make sure we're popping everything off, and this will literally clear out our array. And then we'll go console dot write line, and we go var, and we should be good to go, hopefully. So let's just go ahead, let's run this. Let's step through this with a debugger and kind of just logically look at what's going on. So clear all, and add watch. I always recommend to add watches whenever you are working with data structures and algorithms, because you can see everything down here and it looks really cool. So we'll go here, and it's actually going to initialize it. So whenever you new up something, or whenever you use this new keyword, what's going to happen is it's going to go inside of our class. So we've already stepped inside of it. This is logically kind of like what's happening. We've passed in 10. So what's going to happen? And it just stepped out. I got to start over because I accidentally clicked the step out button. So we'll go down. We're going to go inside. It's going to assign the max size. So what do you think is going to happen? So this will be assigned to here. This is actually going to go up into our max size. So it's going to go down here. Then it's going to go up here. It's going to go into our max size. We actually don't have our array initialized yet. This initialization is going to be actually what's going to happen. And let's actually add some watches here. So we're going to add watch to our stack. We're going to add watch to our top. And let's see these values being created in real time. Let's actually watch what happens with our stack as it's created. So we're going to go down. our stack array is created. Look at that. Our stack array is created. It's initialized all those nulls. And strings are actually reference types, so they're not initialized as zeros. If you were to put integers in there, this would be 0, as you can see with the top. But because strings are reference types, they're actually initialized as nulls. So we're going to go down. Our top is going to be -1, because that's what we initialized it as. And we've already got all that data in there. And our stack, look at our stack. Our stack is still null, but watch what happens as soon as this is executed. We have this beautiful little curly brackets in here with just our stack, and that's because this is like a whole entire object. An array is not an object. It's a totally different type of data structure, and you can always tell an object in the watch or in your debugger by these curly braces. And we've got our stack in here. We can look at all this little neat data that we have that we can view as this thing is actually running. So we're going to go here. Our for loop's going to run. So stack.push, let's go inside of it. Let's see what's going to happen. The way that you actually step inside it is you're going to step into, and you can see what's going to happen. So our top is going to be incremented, and then the top is 0 now. So within the stack array, let's see. So this is our array right here. Watch what's going to happen. This top is 0. It's going to pass in our Squirtle item. And it's a little confusing. I know it's confusing. Just try to follow along. If you don't know what's going on, just see if you can follow along. So we've pushed on a Squirtle to the top of our stack. Isn't that beautiful? Then we're going to go down. We're going to do the same thing with Pikachu. Pikachu. Pikachu, Pikachu. That's a song. So now, wait a second. Why is it not in there? It should be in there. Oh, okay. Let me see. Stack.push. Oh, okay, there it is. I don't know why that one's not being. I guess that's like leftover or something. The value for this is stale due to the problem that occurred while evaluating it. I have no idea what that means, but it's popping stuff onto our stack. So we've got Squirtle, Pikachu, Charmander, Squirtle, Pikachu, Charmander. Okay, so Squirtle, Pikachu, Charmander. So we got, boom. Okay, we got another Squirtle. So it's on 6 right now. And as you can see, it's going up. Squirtle, Pikachu, Charmander, Squirtle, Pikachu, Charmander, Squirtle, Pikachu, Charmander. And it's slowly filling our array. Now it's going to pop. So watch what happens. So we're going to step into our pop. We're going to go down. It's going to hold the old top. And our old top is now going to be 8. So it's going to pop off this one. Then we're going to decrement it. Then where the old stack array is and where our old top is, it's going to be 8. And let me see. So if you followed along, one thing that you may be noticing is that, well, Teddy, you said that when we popped, this Charmander is going to be taken off. It's taken off in a logical sense. It's taken off like people would say, like the term would be like programmatically. In our debugger, that Charmander is still there, but if we were to actually iterate through our stack, it wouldn't be there because the top has been taken off. And even though it's almost like a phantom value, like it's there, but it's not really there. I don't really know what the term would be or like what people would actually call it, but it's almost like a phantom. The Charmander is still within our stack, but our new logical top is different. And so if we were to actually iterate through it and we were to actually do any type of operations, it's still there, but it's not there. Hopefully I didn't confuse you. If that confused you, please leave a comment down the section. Please leave a comment down in the comment section, and I'll help you in any way that I can, because I know this stuff is confusing. So now we're just gonna go blow through, and we're just gonna pop all this stuff off the stack, and you'll see it's gonna be the same exact thing. None of it is actually going to be popped off the stack because our new top is going to be 4. So our new top is 4, but these values are still there. And we'll see the top continue to go down. It's going to go 3, go 2, 0, 1, and our stack has been completely depleted. So let me see. That is pretty much it. I hope that didn't confuse you guys too much. I know that stacks, and I know a lot of this stuff can be confusing. If there's anything you want cleared up, if there's anything that I can do to make you understand this a little bit better, make sure to hit that like button. Make sure to hit that subscribe button. Leave a comment down below. And as always, thank you for watching.